Hello and welcome back to Dave the Game Guy and my astronomy, cosmogony, and beyond PowerPoint. This one is about the power of 5 and the origin of numbers, because 5 is definitively the origin of numbers. It's where they all come from. It's the multiple. The concept of 5 is the all numbers. 5 is the origin of numbers. Is the stack in Roman numerals. By that I mean you go I, and then IV, and then V, and that V is the 5, and then 10 is an X, and then at 50 it switches to. But the ones that bring those symbols are actually the powers at B, being 4 and 9, and 40 and 90, because Greek and Romans typically, counted in intervals of 8 for the most part. Greeks definitely. It's the only repeating number in the Fibonacci sequence at 55, outside of, if you want to count original binary being the start, which is 0, 1, and then 1, 1. But it's 1 and 1. It's two separate instances of 1 versus 55, which is in the middle of everything. It absolutely is. Represents the most indivisible quantity. By all forms of logic, the decimal definition of 0 is a multiple of 5. This is because there is no 0. 0 doesn't exist. If anything, 0 just returns to original state, because if you use the power of 0 on any number, it returns 1, not 0. So therefore 0 is not a real thing. But it's a multiple of 5 if it is. And I'll go through that now with the numbers. So let's see here. I got a pen here. I think I got a pen. Shift and L. And we're going to use the blue pen because it goes with the... Alright, cool. What do we see here? We see that 5... is directly in between the 1 and the 9. These being odd, odd, odd. So all of these numbers are odd. This tells us, by definition, that no matter where you're at, infinity, there has to be more odd numbers than even numbers, based off of the fact that we've got a 1 right here, we got a 9 right here, we've got 5 odd numbers in the original sequence, and we've got 4 even numbers. However, the even numbers are just important. What we also know is that on either side of the 5, we have a sequence of 4 numbers, 1, 2, 3, 4, and we have 6, 7, 8, 9. Right over here, we've got 1 plus 1 equals 2, 2 plus 1 equals 3, and then by the same equation, same factor, that 1 plus 1 equals 2, 2 plus 2 equals 4. So we've got the square of 4, we got the square of 2 right here. And then if we look on the other side, we have 6, which is 2 times 3. We have 7, which is 3 plus 4, but there's a lot more to 7. It's natural false in the universe. And then we have 8, which is 2 to the power of 3. So by the same token that 4 was 2 stacked by 2 stacked by 2, we have 2, 2, 2 stacked on top of each other. And then by a similar nature to this, we have 3 squared right here. And that's how you get 9, is 3 by the same principle that you get 4. So what we see here is we've got a sequence of 4 numbers on either side of the 5, ending in a square and ending in a square. When we think about that critically and logically, we can assume that right here is a breakpoint that should be a multiple of 5. Right here should be a breakpoint that is a multiple of 5. And then a sequence of 4 numbers following these digits should follow. And that's exactly the principle. However, once you get past the tens point, the next square isn't before the 5s. It's actually right there at 16. But we're moving a little off topic. There's so many cool things to numbers. But this sequence of events, this sequence of 1, 2, 3, 4, 5, or even just 1, 2, 3, 4, continues onwards to infinity that way. In theory, it should continue onward into infinity that way as well, because of the nature of numbers. Now, let's check on that. Squares and halves. And this is one of the critical points of 5 being the origin of all numbers, because 2 is to prove truth. When you're writing binary, it's 1 proves it true, so 2 options, and that's it. But squares and halves. So right here, we've got 5 to the power of 1 equals 5. We've got 5 to the power of 2 equals 25. 5 to the power of 3 equals 125. 5 to the power of 4 equals 625. 5 to the power of 5 equals 3,125. 5 to the power of 6 equals 15,625. 5 to the power of 7 equals 78,125. And then on the opposite side, going inwards by a similar yet separate measure, because we're multiplying by itself over here through powers, which is based in the 2 on squares, but it's every number following. We go inwards, which represents halves. And we keep halving right there. And what we get is we get 1 over 2 equals 0.5. We get 1 over 4 equals 0.25, which 1 over 4 can be written as 1 over 2 squared. 1 over 8 equals 0.125. 1 over 16 equals 0.0625. 1 over 32 equals 0.03125. 1 over 64 equals 0.015625. And 1 over 128 equals 0.0078125. So, right there with that little piece of logic as well, because it's only after it breaks the tens place that we see a 0 placeholder, we can assume that the next time we'll see a 0 at the beginning of that sequence as it continues smaller and smaller and smaller into infinitum, that by the time we break that 1,000th place, there will be 3 zeros. By the time we break the 10,000 place, there will be 4 zeros. By the time we break the 100,000th place, there will be 5 zeros, and so forth and so on. Just the same way that the Fibonacci sequence works in the decimal numbers through the digital roots of the Fibonacci sequence. And on just right in the middle, 5 divided by 2 is 2.5. 2.5 divided by 2 equals 1.25. 1.25 divided by 2 equals 6.625. And you get the gist. It's the same. It's the same. It's the only number that you'll get this kind of array of equations. Binary in this principle. Binary is written as ones and zeros, with the ones acting as powers of 2 for the computer to add. For example, 0, 0, that equals 1, 2, 4, 8, 16, 32, 64, and 128. So, what this tells the computer to do is if wherever that 1 is at, it'll add that integer. So, by that definition, you know that if there's ever a 0 in this last place, it's going to be an odd number. But like, 1010 would be 10. 1010. But look at that purely because pay attention to those numbers and how they arrange themselves. And we're on. By powers multiplied, 5 to the power of 1 times 2 to the power of 1 equals 10. 5 to the power of 2 times 2 to the power of 2 equals 100. 5 to the power of 3 times 2 to the power of 3 equals 1,000. 5 to the power of 4 times 2 to the power of 4 equals 10,000. 5 to the power of 5 times 2 to the power of 5 equals 100,000. 5 to the power of 6 times 2 to the power of 6 equals 1 million. And 5 to the power of 7 times 2 to the power of 7 equals 10 million. Which, by looking at those numbers simultaneously with the binary equivalent of where the power of 2 lines up, it lines up perfectly with the multiplied power of the equivalent 5. Therefore, I think proving my point by all forms of logic that 5 is the original integer. It's the original bit. It's the original digit. It's the start and origin of numbers. My thoughts: Jupiter's the computer of the solar system. Jupiter's the 5th planet of the sun. Its electromagnetic gravity keeps everything in check so that the sun has reverse polarities and able to stretch out to the Kuiper belt and whatnot. But tune in next time as I continue unraveling astronomy, cosmogony, and beyond as I talk about monad theory and the indivisible soul. And these are pretty much all my own theories. This is my thought process. The guy who made this video, this is what I've found. This is my research. Anyway, have a lovely day. Thank you for tuning in.